Thanks. Again, excited to be here, talk about building distributed and decentralized AI. Last year was an exciting experience to bring the RAG bots, it was called then. Now, marketing department wants to call it agents, right? Bot is not cool, it's agents now. It'll continue to evolve, but at the pace at which things are changing, I think at Quai we have this 2 years of worth of discussions which has to materialize in some way or shape, and there's a lot of good thoughts that float around in the work groups, and I myself go through these thoughts and try to stitch these puzzle pieces, and I'm excited to say that this year we are able to distill some of those thoughts and materialize it in the form of a QuaiNet and see how we can transfer the value to the community. So with that being said, we are introducing a test network, QuaiNet. It is starting at the humble beginnings where the framework is borrowed from the Petals framework. Thanks to Brian Ragazzi, if he's here. Hey, Brian, are you here? Hey, Brian. Come on up here. Come on up here. I would like to, yeah, I wasn't sure whether Brian would be able to travel today, but so thanks to him, he introduced us to this Petals network, and we are able to visualize some of what we were talking about in actionable items. So let's see what's the motivation here. The motivation we started with Lumi version 1, which is a local RAG bot that was at that time, was that it is expensive to run it or host it in the cloud or even locally for someone with a gaming computer. You need deeper technological knowledge to do that. Higher cost. The cost here essentially is not just of a monetary value. We soon realize, if you've been through all day of this symposium, that it's more than cost. It's your privacy, it's your data sovereignty, and how you, what's your agency, and all these questions sum it up into one higher cost. Personal AI, right? That's another motivation for Quai, right? You have heard many talks about personalized AI and personal AI, and what's the distinction between these. Self-sustainability. For Quai, it's very paramount that the community sustains itself and able to provide resources for the community to research and develop and augment the vision of Quai. Data contracts, in one form or another, being talked about. Dr. talks about this in his IEEE. So we know that data occurs in layers, right? It starts with you, your personal data, then it becomes your family data, then your community data, and then your wider world. So data disseminates in different tiers, and how do we go about getting from a me to be economy or me to you economy in a very responsible and protected fashion? And that's the core of all this effort. So distribution of AI workload. We see the hardware manufacturers like NVIDIA have NVLink, which goes inside the data center for very low latency, offloading some of this to distributed units. We have other AI chipset manufacturers exploring PCIe or other forms of hardware technologies to distribute. What do we have? We have the internet, right? We have the TCP/IP, yes. It is decentralized, yes, the internet runs on it, but it has its varying network properties. So the challenge here is can we really get distributed inference and training going? And that's what the core, the light bulb moment went on when Petals has already done it. They actually had a TechCrunch article in December 2022, which kind of probably got buried after ChatGPT got released. And when Brian introduced it to us, the Petals project itself was a little quiet, but we kind of sort of, with group effort, revived the whole project back into another form that I'm going to demonstrate. So what's the formula? So essentially, we have the Petals, HiveMind, DHT, and libp2p, which you have heard about in the cryptography talk track. Develop an OpenAI compliant API layer to the Petal nodes. So that's the piece that came together eventually. It was, over time, people, again, there's multiple standards in this API business, right? And OpenAI, RESTful API became popular, so it's now becoming lucrative to plug the system using that standardized method because there are many tools like OpenWebUI that can consume that type of API. So package the workload into Docker, connect the API to OpenWebUI, and thanks in part to Zach and crew who brought in the OpenWebUI version of Lumi that encouraged us to, let's plug that in and make this demo possible. And most importantly, give the ability for people to deploy their own private community network. So again, it's beginning of the framework. Not all of it is done. Like I said, it's not, we're promising everything, but it's starting at the ground floor, trying to build all the components that we talk about inside Quai, one by one, layer by layer, like Doc says. Nobody's going to build it. We have to. So what does the architecture look like? So Brian, would you like to talk about the whole petals architecture?
Hello? Okay. Yeah, so the Quinite architecture uses a, well, it's a distributed model. Although this is not the original graphic that I had, so trying to speak to it will be a little bit different. What happens, though, basically is a new node connects to the network, and they hit a bootstrap node. So that has an actual well-known address. Can you hear me better now? Okay. Wow. Okay. So. Hello? Okay. All right. Wow, that's almost too loud. Okay, so a node joining the network will, let me get farther away, there we go. A node joining the network will hit a bootstrap node. So the cluster has a set of bootstrap nodes that have published addresses. A new node will connect to that, and that will connect it to the distributed hash table, which is not listed here, but that's the center of the whole thing. That's the common state and communication between nodes in the cluster. So then it uses libp2p, so if you don't have a globally addressable IP address, if you're behind a NAT or something like that, then it will create a gateway so that the other nodes can communicate with your nodes. You don't have to be on a cloud provider with a public IP or anything like that. You can run this out of your house and participate. I don't know if is this the whole thing or is there a further?
That's good, Brian.
Okay.
I think, so I'll explain this particular part where this is how, again, not all the pieces of the petals is listed, but just wanted to show how we have grouped in the Quinet. There's an API layer for each distributed model, and then below which there are nodes here, which operate responding to that particular API layer. So we'll do a short demo to see how this all works. So this is, again, a small group of individuals participating in the Quinet. We wanted to intentionally distribute it coast to coast, East Coast and West Coast. If you look at the table, there is Suleiman Sadori who has contributed. Again, we requested people to list voluntarily. It's not gathered from the machine, but they tagged it. So you can see a Xeon E3, there's a GTX 1080. So some of these graphics cards are probably 10 years old. Like I have a 1060. So you can see there's a wide array of devices here. Some of the locations which are relay items these are not accurate because they are not being transmitted, the IPs. But again, the logic I have is probably a little buggy trying to pin everything to Las Vegas for some reason. Palace Word is definitely mine because I shared a direct IP address, so as you can see. So the distinction between direct and relay are the ones that are behind the NAT and firewall versus people who want to actually contribute towards direct addressability, and there's a reason for that. Right.
Yeah.
The direct node and the relay node. What's the reason why you want a direct node? Okay, so the topology part, I tried to come up with this diagram just to group with in a short period of time. But you can see there are 2 bootstrap servers for this demo. There's a couple of API server nodes for each model, and there is individual different shaped objects because they come in different sizes, nodes below it, and these are all active and real right now. So what we have done is expose this via OpenAI compliant RESTful API, plugged it into OpenWebUI, and created 3 different models, as you can see here, to run the RAG agent, not a bot. So the local Lumi, we call it, which is running within the Docker container using a Llama instruct locally. The Quinet 3 billion is hosted by a few nodes here. As you can see, if I sort by the model, you can see there's 3 billion models and 8 billion models. It's set up in such a way that no single node owns all the blocks. The Llama 3 billion has 28 decoder blocks, and you can see it's split between multiple nodes. The similar case exists with the 8 billion, where no single node is owning all the blocks. And this is critical for this demo because it has to be proven that it will work in a distributed way. So with that said, we have 3 side-by-side, thanks to OpenWebUI. There's a few underlying things with this particular demo is that it's already doing a few things more than last year. Essentially, when a query gets submitted, it goes through a task agent, which is a local Llama model that runs tasks like auto-completion or title generation or tags and stuff. But the main inference job gets to the Quinet model. So we'll pick a random question here. Send it along. So obviously the local one should respond first. All of them will complete the knowledge request faster because it's local task, retrieving all those chunks. And now it's being submitted. Obviously the local is faster. And the next 2 depends on the speed and how they are connected. And we can look at the table. Each of these nodes have different speeds and different latency measures. But still, nevertheless, they're coming back with a response, same as the local node, streaming from the community inference. And these are same instruct models, quantized slightly differently. We'll get into that. But as you can see, it's still coming back. Again, we have not done any performance improvements yet, like the OLAMA or other API endpoints where batching and caching and all kind of other fun stuff. It's just one token at a time being tokenized and passed through. So the response speed is probably in line with what I would expect without optimization. All right, let's go back to the quickly. I just quickly walked through a few things here. We did do benchmark with Grafana K6 for load testing and these Docker setup. And the primary driver we are going after is Petals. Real-world server, 32 tokens per second on a single batch size, or 179 for 64 batch size. That's the configuration they used. And with OLAMA local, which is, again, different protocol, different type of API server, I was getting about 100 odd tokens per second. With the Quinet API, probably close to 2. With one node hosting all 32 blocks. This is east and west with 2 nodes, 16 blocks each. This is two node setup for 3 billion. So lessons learned. Again, much of this is developer, but most critical thing is probably we have to tackle the quantization problem native to the graphics card to push the boundaries and batching. Those are the 2 things probably that will follow up. In a high level, where do we go from here? There are a few tasks, as we have listed here, that we will continue to pursue. And Brian is actively pursuing the distributed RAG architecture implementation, which is going to be next layer on top of what we are doing here. Brian, we have a few words about the distributed RAG architecture that you're working on.
We're out of time here. We are going to move into